Okay, good morning to everyone. I hope you are all doing good. The last time we ended our training at the front and back panels of a computer. The front and back panels of a computer. Today we shall look at the cache memory. The cache memory. I already mentioned this cache memory when discussing the motherboards, but many of today's processors also include their own built cache. They include their own built cache. The cache is a quick form of memory that greatly speeds up the performance of your computer. You will see three different cache designations as we go on. Level 1 cache is also known as the L1 cache, and that is the smallest but the fastest of all the cache memories, and it's on the processor die itself. In other words, it's an integrated part of the manufacturing pattern that needs or that used the stamp the processor pathways into the silicon chip. You can't get any closer to the processor than that. Okay. So while the destination of the L1 cache has not changed much over the years, the same is not true for other cache levels as well. So we have the L2 cache, and then we have the L3 cache. Used to be on the motherboard, but now has moved on the die in most processors also. The biggest difference are the speed and whether they are shared. So now the L2 cache is larger, but a little slower than the L1 cache. It is larger, but a little slower than the L1 cache memory. For processors with multiple cores, each core will generally have its own dedicated L1 and L2 cache. So a few processors have a few processors share a common L2 cache among all processor cores. A typical increasing order of capacity and distance from the processor die is the L1 cache, then we go to the L2 cache, then we go to the L3 cache, and then we go to the RAM. So you realize that I have arranged them in hierarchy order, which means that in increasing order of capacity and distance from the processor, it is the L1 that comes first, then the L2 follows, then the L3 follows, then we have the RAM. Okay, this is also the typical decreasing order of speed. So the decreasing order of speed, no, the RAM is the least. The L3 cache follows, L2 cache follows, then L1. I hope you understand. So I have a list that represents the capacities of these memory types. Let me see if I can get that in the hardware training for you. Gosh. Okay, I think I don't have that one right now. I don't have that now. All right, so this is how it is like. The L1 cache has a 64 kilobytes, which is equivalent to the 32 kilobytes each for data instructions. You can note that one down. You can note it down. The L1 cache has 64 kilobytes, which is 32 kilobytes each, 32 kilobytes each for data instructions. The L2 cache has 256 kilobytes. The L3 cache has 4 megabytes to 12 megabytes. The L3 cache has 4 megabytes to 12 megabytes. But then the RAM has 4 gigabytes to 64 gigabytes of RAM. 4 gigabytes to 64 gigabytes of RAM. Okay.
Can you come again on that again?
Okay, so let me come again. The L1 cache has 64 kilobytes. The L1 cache, which is the smallest but the fastest, has 64 kilobytes, which includes the 32 kilobytes each for data processing. 32 kilobytes each for data processing or data instructions. Data instructions. The L2 cache has 256 kilobytes. The L2 cache has 256 kilobytes. The L3 cache has 4 megabytes to 12 megabytes. The L3 cache has 4 megabytes to 12 megabytes. The L3 cache has 4 megabytes to 12 megabytes for each for data instructions. But then the RAM, which is the slowest, that we think is the fastest, you'll get to know another type of memory that is the slowest. We'll get there. We'll get there. So the RAM among this list, it is the RAM that is the slowest, okay, which is a 4 gigabyte to 64 gigabytes. 4 gigabytes to 64 gigabytes. 4 gigabytes to 64 gigabytes. Are you okay now? Okay. Now let's, any question?
Please, you said the RAM, what was the size? I didn't get that side.
The size is 4.
Which is the slowest?
Yeah, the 4 gigabytes to 64 gigabytes. 4 gigabytes to 64
okay.
gigabytes. Yeah.
Okay, thank you.
Okay. Now let's look at, I have spoken enough about the memory. The last time I told you there is something we call binary. There's something we call binary. We have not really experimented that. I want us to give, I want to give you a short scenario about what the binary is, how to convert from the binary to hexadecimal to octal to decimal and all of that. Let's see how we can do that. There is a mathematical calculation for all of that. You understand? I think right there back in GSS, in SS, in the tertiary, we learned how to calculate for what? From hexa or from decimal to binary, from binary to decimal and all of that. Okay. Now we can use the calculator to do that short calculation. But when we get there, I'll show you. So in Windows 10, let's open the calculator in Windows 10. So I'm using Windows 10 right now. You can start writing the steps down. Okay. So in my system now, the short form I can use to open the calculator is to hold the Windows logo key and press R. Then I type CALC. CALC is a short form of calculator. That is not just a short form, but this is the command that would open the calculator application for me. Then I click on OK. Then the calculator will be launched. Now the calculator is launched for me. Can you all see my screen? Can you all see my screen?
Yes, please.
Okay, sure. So you saw the process I used. Let me start that again. So in Windows environment, okay, Windows 10 precisely, because that is what I'm using right now. You hold the Windows logo key and press R. Then you type CALC. Then you click on OK. When you click on OK, it will launch the calculator application for you. So you click on the calculator menu. So this is the menu. This 3 dash here you see here is the menu. So when you click on it, you choose programmer. So I click on it. This is viewed in the programmer mode right now. You will notice on the left pane, so in the left pane here, that the deck has been selected by default. The deck has been selected by default. So deck is the short for decimal. Deck is the short for decimal. Hex is a short for what's the name? Hexadecimal. Hexadecimal. Oct is a short for octal. Oct is a short for octal. Then a bin is a short for binary. Okay, so by default, you will choose the same deck option here. Okay, now I'm going to just enter a number, and the number I'm going to enter is in decimal. It's in decimal, so I'm going to type 267. 267. You notice that Carl, the calculator, shows you the hexadecimal, which is a hex. Okay. Now, this 267 that I've just entered, you realize that the number has been converted into binary. You can see that here. So 267, when you, the user, enters this value, the computer translates it into this digits. Okay, it translates it into this digits. Now, when you click on the binary, you will notice that all the number keys are now grayed out except the zeros and ones. So I'm going to click on that. So you see, instead of saying the 000, 1000000, the zeros here are 4, 1011. Okay, as displayed here, you are now going to say this. You're now going to say this. The first 3 zeros are taken off. Now, I told you the meaning of the 1 and the 0 in binary. So for a flashback, you realize that the 1 means on and the 0 is off. Okay, so you have 1 on, off, 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 on, off, on. That is the implication of this. When I click on the binary, I also realize that all the values here are grayed off except 0 and 1. All the values here are deactivated or grayed off except 0 and 1. I hope you understand, you get that. Okay, so let's just continue. Now I'm going to click on oct again, the octal. When I click on octal, we realize that all the values here are from 0 to 7. All the values here are from 0 to 7. Oct is base 8 or is less than 8. So you don't have a value that is in 8 or base 8, and then you get up to 8. 8 will not be included. I hope you understand. So the 267 I entered, okay, this is how it's going to be like when you convert to oct. You understand? Now, hex, or you've done for bin already, you've done for oct. Let's go to dex. Dex is going to give you the same value, decimal, you understand? Now, let's see for hex. Hex is going to give you the same value from 0 to 9, which includes A, B, C, D, E, and F at the same time. That is hex, hexadecimal, hexadecimal. So hexadecimal goes beyond the numbers. It would include alphabet. That is why you have 10B included to this one. I hope you understand. There's a mathematical calculation for this, but for the purposes of our online training, we are using this programmer calculator for that. Now, if you have an older version of the calculator, you will need to click on the radio buttons next to these options to perform the conversions. I hope you understand. Okay, any question whatsoever? Any question now? Any question about binary? Okay, let's talk about the memory. Let's talk little about the memory. I have discussed with you so many times about what the memory is. I told you the memory is one of the components in the computer that helps in the actual processing of data. I also told you have two types of memories. We have the RAM and then we have the ROM. I told you what the RAM does and I told you what the ROM does. I gave you the difference between a RAM and a ROM. You understand? I say one is volatile and the other is non-volatile. Volatile means what? I hope you know all of that. Now, today, what I want our emphasis to go on is the virtual memory. The virtual memory. Virtual memory is not like a physical memory. That's why the name is virtual. Virtual memory is not like the physical RAM you see on the computer. Okay, let's look at what the virtual memory really is. Is it a kind of memory that you have to go to the market and buy? Is it a kind of memory that it can be upgradable? Is it the kind of memory that the bigger it is, the faster your processing capabilities are? What at all is the virtual memory or the VM? Many OS, including Microsoft Windows. So you know there are types of operating systems. Windows is not the only operating systems in the market today. I hope you know about that. So we have other operating systems like the Mac, the Red Hat, and others. Okay. Even on our phones, there are operating systems in it. On our mobile phones, it has operating systems. You understand? You need to check out for the operating system that your phone comes with. I hope you understand. So our emphasis today is on Microsoft Windows because that is what is generally used. That is what is generally used. So many operating systems, which includes the Microsoft Windows operating system, use a tremendous amount of RAM. Seriously, the more applications you open, if I should show you the number of applications I'm running right now concurrently on this laptop, you would be marveled. Okay, so these are the active ones right now. My mail, my corporate mail is opened. I have my messages opened. I have and this particular one, I have about 9 or more of web apps that are running at the background. Look, all these ones are taking some amount of memories right now from my physical memory. I have another one too. I have BlueStack also running. BlueStack alone takes so much memory from the computer. Anytime you install BlueStack if you have ever used BlueStack before, when you install BlueStack on your computer, you realize that your system goes, almost half of your memory goes, is apportioned to BlueStack. You understand? And other applications that I'm running right now, which includes the Zoom player I'm doing the training on right now. So that gives you an insight of the amount of memories that is consumed even when you are running an application. I hope you understand. I'm talking about the open applications right now. What about those applications that are running at the background that you have not even instructed the computer to open for you, but the computer decided to open by itself? What about those applications? An application like, for instance, when you have installed an antivirus on your computer, You understand? The antivirus will protect your computer for you, and that is done at the background of your operations. It's done at the background of your operations. Okay. You have other applications that will have to run at the background. Let me check this out. When you hold the control key, the shift key, and then the escape key simultaneously, all the three keys are pressed simultaneously. Control, shift, and escape. It will give you a list of applications that are running through the task manager and the amount of memory that is consumed. So, okay, so as we speak right now, the system is showing you the CPU performance, the amount of memory or the amount of space, amount of processing capabilities of the CPU as we speak right now. Okay, so this is a graph that is displaying the performance for you right now. It's uptime. It's uptime now. Then we talk about the memory. This is also the memory usage right now. The memory usage right now. And then the hard drive, the hard disk usage right now. All these processes are shown to you. The network, this is the Ethernet network. So the Ethernet network, I'm not using Ethernet right now. The Ethernet network is the network adapter, okay? The one that uses the RJ45, okay? But this is on VM. The VM is a virtual machine where, okay, this is the second one. But this is the Wi-Fi. The Wi-Fi I'm using right now, and it's connected to a SSD, Microsoft, blah, 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 blah. This is the IP address and all of that. We'll get to that in advance class. But this is the network. Look at how the graph is being displayed. You understand? Look at how the graph is being displayed. So this is how your system is utilizing the resources in the computer system. Let's go to the process. Let's go to the processes. Now, it has given us the processes. Now, the system is right now using 82% of my physical memory. Look at how it has been apportioned. Look at how it has been apportioned. Now, Chrome alone is using about 345 megabytes of my system memory. Chrome alone, the 13 tabs that I open in Chrome. I've also opened 7 tabs in Microsoft Edge. BlueStack is using, currently it's using 60.9 megabytes. You understand? So these are the applications that are running at the background. These ones too. These applications are running at the background that I did not instruct them to open, but they are necessary to be run or to be launched at the background of my my operations. You understand? All these applications are running. And so you realize that even before you start using the computer's memory to run your applications, a portion of your memory has already been exhausted. See, all these applications are running at the background. All these applications are running. The amount of memories that they consume is being displayed here. Okay, now I want to run specific applications on the computer. Let me just close this. Yeah, it should be okay, right. Now I want to run specific applications on the computer. Sometimes you realize that the system uses a tremendous amount of RAM as they operate. So they sometimes do this to the point that even a well-equipped PC or a well-equipped computer might not have enough memory to operate and do all that a user wants to do. To prevent the user from being denied access to an activity because of the lack of available memory, this OS or the operating system that we use, they employ a virtual memory to take up the slack. They employ a virtual memory to take up a slack. So going forward, I will not say virtual memory again. I'll use the VM. Okay. So now with VM, a portion of the hard disk. So now we are going to look at what the VM means, what the VM actually means. So the VM, it means that the system uses a portion of the hard disk, a portion of the hard disk of the hard disk. A portion of the hard disk is set aside as a holding area for the contents of the RAM. A portion of the hard disk is set aside for a holding area for the contents of the RAM. Now, when there isn't enough RAM space in RAM to hold the data that needs to be placed, the OS virtual memory, okay, or the OS VM management utility temporarily moves some of the least recently used data in RAM onto the hard drive. It's by so doing, it makes room for the incoming data. Then if an application calls for the data that was moved out, the VM manager moves something else and swaps the needed data back in again. Because of all this data swapping, that the back and forth and stuff, the reserved area on the hard disk for VM is sometimes called a swap file or page file. I hope you understand. The reserved area is sometimes called a swap file or a page file. What it's trying to say is that when you install a memory into the computer, as you use the applications installed on the computer, and sometimes you go online, some of the applications are not physically installed into the computer, but you go online to get a full benefit of those applications. All those things consume part of the memory. And the more the memory is consumed, the lesser the leftover for other applications to run. So it will get to a point that the memory will be exhausted. You don't have any memory left to run additional application. But you, the user, will not know. You will not know. Now, a portion of the hard drive space has been designed in such a way that when your memory is exhausted, the system automatically leans on the free space of the hard drive. Now, you also get to know that the hard drive is the slowest. Last time I was telling you when we were talking about the memory, right? Now, I told you among the cache memories, it is the physical RAM that is the slowest. Right now, I'm telling you again that in the entire system, when you take the hard disk, the memory, the CPU, the bus, the cache, all this into consideration, the slowest device in the computer is the hard disk. It's very slow. Now, it's slow because of the spinning nature, how it retrieves data. You know, I told you when we were discussing the hard disk, I told you all the sectors of the hard drive. That spinning object in the system or the hard drive where it picks data, the cluster. What it does is that because it's spinning, it takes a while for the system to retrieve data from it. I hope you understand. Now, an assignment I want to give you right now before the main assignment is to go and look out for RPM, the meaning of RPM. Last time I gave you an assignment too. I have not received that yet. I'll take it before we go. RPM. So sometimes you get hard drives that you are not looking at just the capacity of the hard drive, but you are looking at the RPM of the hard drive as well. So sometimes you have hard drive RPMs like 5,000, 2,000, 5,400 RPMs, 10,000. Is it that the higher the RPM, the faster its operation, or the higher the RPM, the slower its operation? That is a question for you to go and look out for when we meet again on Monday. But for the purposes of our tutorial right now, I want to tell you that the higher the hard disk gives out space to the system for processing, the slower your computer becomes. So it is rather the opposite. Because the hard drive is the slowest device in the computer, the more space is given to the system for operations, the more your system goes slow or runs slow. The lesser space it gives to the system for operations, the faster your computer runs. That is as simple as that. Okay, so if the system tells you that the minimum system requirement for running Windows 10 is 4 gigabytes, it is trying to tell you that if you are using 4 gigabytes to your memory is 4 gigabytes, and you install your applications, you store your operating system onto the computer, you should note that that is the minimum for the operating system. Other applications will also be installed, and they would like to rely on the same 4 gigabytes of RAM. Then you say, you would install 2 gigabytes. The last time you installed 2 gigabytes on the system and it's worked, yes, it will run. 2 gigabytes will run on Windows 10. But as soon as you are done with the installation and you use the computer today and tomorrow next, it will start running slow. Even before you start installing your applications on the computer. Now, when the applications are added to the computer, the system will now lean on the free space of the hard drive. And the bigger the free space of the hard drive that is assigned to VM, the slower your computer runs. The smaller the free space assigned to your VM, the faster your computer runs. I hope you understand. Okay. So the main drawback of VM is its speed. That's all. It's just the speed. So if VM were designed in such a way that when VM is launched, okay, it runs faster, people will not install higher memories on their computer again. Yeah, if I know very well that VM is there, I'd rather love to free space on the hard drive to make way for what? VM. Yeah, which is limited to the speed at which the hard drive can store and retrieve data compared to speed of the processor and memory, like I told you earlier on. So when you compare the speed of the processor and the speed of the memory, the hard disk is very slow, very, very, very slow. That is the slowest component in the computer. Therefore, the less physical RAM available in the system, the more the system has to rely on VM. So if you don't increase the memories of your computer system, the more the system relies on your VM. And the more slowly applications will run on the system. That's why adding more RAM to a system is worthwhile upgrading. You understand? So if you have enough resource, I mean, if you have enough money to do an upgrade of your computer, do an upgrade of the RAM more. You understand? Especially when you do, your system is designed to just do data works. For the system I'm using right now, it is designed to run applications online most often. It is just recently that I've added other things to it. Okay, so most of my applications that I'm running are basically running online. That is why I have so many tabs open in here. I hope you understand. And so the last time I was, we were using the computer that it went off, I realized that an 8 gig of my memory was getting damaged. And so when you check on the memory capacity of my system right now, it has reduced to, I think, 6 gig or so. That should reduce to, I think, 6 gig. Yeah, so the installed RAM is just 6 gig. You understand? And 6 gig By the time I'm done with your training and I start another one at 12 o'clock and I am done, the system will start running very slow. Very slow. And I know at the point that it's running slow, it is leaning on the hard disk space. I hope you understand. It's leaning on the hard disk space. Now, I'm told I have only 10 minutes more left. There is an assignment that I want you to do. There's an assignment that I want you to do. Let me see. Let me give you a clue about the assignment so that you can go and get it done and see how the VM really operates. So exercise 1, this is how it goes. So if Enoch would push all these informations to you on the platform, in the mastermind page, okay, and when he pushes them to you, you would know how it is really done. So accessing your computer's RAM and virtual memory. In Windows 10, click Start and type this, which will show this PC desktop app. It will show this PC desktop app. Right-click this PC and click Properties. So when you right-click this PC and click Properties, this is what is going to appear. Alternatively, open Control Panel, System and Security. That is, it's giving you the long process here. Okay, you will get a setting or a screen similar to the one shown here. So after you go through this process, this is what would appear on the screen. The second step is in the system section of the page that appears. So in the system section of the page that appears. So over here, this is the system section of the page that appears. Note the amount of memory installed on the system. So you must identify the memory. So in this scenario here, 8 gig has been installed. That is the physical amount of memory you have in the computer. So in the bar at the left, click Advanced System Settings. These Advanced System Settings, you click on it. The System Properties dialog box will open. On the Advanced tab in the Performance section, click Settings. The Performance options will also open. Now let's go to the second one. We ended at 4, right? I think this should be the 5. So the 5th one is click the Advanced tab, and in the virtual memory section, note the total paging file size for all drives are shown in figure 1.18. This is the amount of virtual memory sets aside for the system's use. So I'm going to show you that bit too. Yeah. So when you go through that process, this is what you will get. This is what you get. So these are performance options that it was telling you about. When you click on the advanced, you have programs. It says adjust for performance, adjust for best performance of programs, background services. So this is a virtual memory that system was using. A paging file is an area on the hard disk that Windows uses as if it were using your RAM. You understand? So if you change it and the size there goes bigger, then it means that when your system uses all the memory that is assigned to it, it will start leaning on this one and it will be very slow instead. You understand? So click the change button over there. The virtual memory dialog box will appear. Let's go to the next option. Then it says, click cancel to close the blah, 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 blah. You understand? Click cancel to close the performance options dialog box. Click cancel to close the system properties dialog box. Close the control panel window. You understand? So this is an assignment that will be given to you. Enoch will send all these information to you on your platform now. I hope you understand. So that ends the class for today. Any question? Any question whatsoever? Any question?
Hello.
Yeah, hello. Yeah.
I heard of blue stack. I was trying to, it's like something I tried to install on my laptop sometime, and I realized it was not giving me the access to what I actually wanted. So I want to know if it has other uses. What is the main purpose for?
Your question again, please. I'm not getting you clearly.
I mean the blue stack.
Yeah, the blue stack.
I know it's a software app that runs like this Android or something.
Yes.
But I want to know its actual use.
Its actual use.
Yes.
Okay, so the blue stack is designed to act like or let's say a mobile phone inside a computer. And so everything that you would love to do with your phone, your handheld physical phone, okay, you can do same with BlueStack. So when you go to the market and you buy a new phone and you want to install applications on it, currently what it will request is your Gmail account. So you put in your Gmail account, your settings and everything. It will download all your contacts in Gmail for you. Then you go to Play Store. So in the Play Store settings where you will select applications that you would install. So in my BlueStack, typically what I wanted to do is that to install my WhatsApp. Sometimes I realize that my phone gets overly exhausted because of the activities that I run with my phone. I'm even using 8 gig ROM, but at the point in time, it goes off. It goes off, it has to restart. And so I'm gradually moving some of my applications on the computer. As for the computer, maybe I can just go to the market and upgrade the RAM. I hope you understand. If I upgrade the RAM to it, then it means that it can perform several other options so that I can free my phone from other things that would slow it. I hope you understand. So in the BlueStack, you can install all the applications that you would wish to install if you're using the phone. I hope you understand. So WhatsApp is one. Yeah. You can go ahead.
Okay, I know with Facebook, also that one is just having internet access, you can just access your account.
Yes.
But with the WhatsApp, you need to connect the phones by using the WhatsApp, what do you call it?
Web.
Yes, WhatsApp web.
Yeah.
Get your phone connected to your laptop.
Yeah.
That's it. But without the phone, I initially got one idea from someone. I said you can use the Android emulator. I don't know if that one works.
You initially brought what?
Android emulator.
Android emulator. Okay.
Yeah.
Okay.
I don't know if that one too can give you access to, let's say your WhatsApp instead of using the phone.
Okay, you are asking whether Android emulator can do the same as using the phone.
Yeah.
Yeah, so it's an Android emulator. That's the Android is operating system. You understand? So you can equally use the Android emulator. There are various forms of this softwares. We have another one too. We call the what's the name? Clone phone. We have clone phone. We have there are several of them. There are several of them online right now that you can download. They all perform the same function. You know, they are all from different vendors, and the features that comes along with them are different. I hope you understand. So you can try all of that. Like I was saying, the WhatsApp web, as it stands right now on Crapo, I think the WhatsApp web has been designed in such a way it has been upgraded so that you can even scan 4 different devices with the same Android. You know, initially when you scan your WhatsApp on a phone, on a computer, and you go and scan on a second computer, it will close the first one. By this time, it doesn't work like that. You can scan up to 4 devices and to still perform the same thing for you.